Hi everyone, my name is Ilsung Lee and I'm a senior product manager for the Google Cloud working on key management and obviously Cloud HSM. And with me, I have Adit Sinha, who's one of our tech leads for Cloud HSM to talk about Cloud HSM and give you a deep dive and best practices around the service itself. Now, in this session, we'll talk first about the HSM overview and give you an idea of what Cloud HSM is and what it can do for you, and then highlight some of the key features for Cloud HSM. And then I'll turn it over to Adit, who will actually talk more about the overall architecture and talk about some of the key aspects of the architecture, such as the tenant separation and the Google administrative access. So start off with let's go and talk a little bit about the overview of Cloud HSM. So that picture there is actually a real picture of one of the cards that we have inside our data centers. And this is a Cavium Liquid Security HSM. That black stuff you see all around it is actually epoxy that's used to provide the tamper evidence and tamper resistance for the card itself. And it's one of the requirements for the card to be a FIPS 140-2 card. And I'll explain a little bit more about that in a bit. But the Cloud HSM service is basically HSMs as a managed service. And so if you're not familiar with HSMs, they're hardware security modules. They're basically industry devices that are used, hardware devices that are used to actually protect, generate key material, and also perform crypto operations. Now, the Cloud HSM that we provide is actually a fully managed service that Google provides, as you can see in the diagram there. A request comes in, it goes through the key management service front end, and then based upon the type of key you created, it either goes to the software path or the hardware path. And if it's in the hardware path, our Cloud HSM service will orchestrate the operations to occur within one of the actual physical HSMs. So the the architecture actually lends itself to being a full cloud service, and I won't talk too much about this because in a few slides, Audit will talk more about this. But what I mean is that we'll take care of all the patching for you, so you don't have to worry about any of the physical maintenance, firmware upgrades, or anything else like that. It's all done without any downtime, so it doesn't really make a difference. It doesn't really impact you from an availability perspective. We also auto scale this in terms of requests as well. So if you have a lot of requests, then our service will just be able to fulfill all those requests as well within the limits of your quota. And the other thing is that you don't have to worry about backups and having any kind of business continuity strategy because we'll take care of that for you as well. So we'll take care of the backups. We have a very highly redundant system that makes sure that your key material is very secure and that the chances of losing your keys are actually extremely small to almost completely unlikely. And the other thing about the HSMs as well is that they're all contained within our very secure facilities. So they're basically inherit all the physical securities that all our servers and all the other devices have within our data centers, and they basically provides a level of security that it will be pretty hard to impersonate outside of a cloud provider. Now, why would you use Cloud HSM? There's a number of reasons. So, number one, it's typically compliance. So, a lot of people use Cloud HSM or HSMs in general because they're looking for a certification from NIST. And it's essentially FIPS 140-2 level 3 that our HSMs are currently running in. Now, what that means is that the FIPS 140-2 is a crypto standard devised by NIST again, and it defines things like what your random number generations, the type of algorithms, key types, things like that. The level 3 is basically only attainable through hardware devices, and it dictates things like the physical tamper evidence and tamper proofness of the device itself, so that you can't get in there and physically like try to extract the keys, or it's very difficult to do so. Regionalization is also another key aspect of the service where when you actually create a key within a specific region, let's say that it's US Central 1, then that key only exists within US Central 1. And not only the key, but also the metadata, all the backups, everything else associated with that. So wherever you create the key, that's where it'll be. Now, Cloud HSM also provides an additional level of regional affinity based on the fact that when you create the keys, it's associated with a set of HSMs that are physically within that region. If that key was ever, if you ever try to actually decrypt that key in a different region, it's not possible. And you'll understand what I'm talking about a little bit more when Ada talks about the architecture, but essentially that key can only ever be used by those devices within that region. And then finally, the last thing, and I'll just reiterate, is that it leverages the exact same APIs as Cloud KMS. And what that really means is that if you already know how to use Cloud KMS, then you know how to use Cloud HSM. And any application that uses Cloud KMS can use Cloud HSM, including all the internal integrations that we have as well. So all the services are integrated with our Cloud KMS. We'll be able to use HSMs without any kind of changes. It's only when you create the key you specify protection level, and that's it. Now, talking in terms of key features, there are three that I'd like to actually kind of cover in a little bit more detail. And those are the global multi-regional support, the attestation statements, and the CMEK integration. And CMEK stands for Customer Managed Encryption Keys. Now, in terms of the global multi-regional support, um, first of all, we have Cloud HSM available in all our cloud regions. So any region that you choose today should have Cloud HSM available with it as well. And so, it has a large footprint, and it's probably one of the largest, footprints for HSM service that you'll find anywhere, to be quite honest. The other thing is that it will be you have the capability of actually creating a multi-region with our Cloud HSM keys. And what that means is that when you create a key in a multi-region, it's available across that geography. So, for example, if you create a key within the US region, then that key is accessible through different areas within the United States. It's available across the country, so that if for whatever reason your particular region goes dark, which hopefully never happens, then that key exists in other areas and other regions or not other parts of the country, so that your application can migrate over to a different part of the country, and the key will just be there. It'll be completely available. And when you make changes to a key in a multi-region, the changes are reflected everywhere. So it happens in almost instantaneously. So it's truly a multi-region. It's not a backup and restore. So in other schemes, you may see systems where you actually are basically taking your backup and restoring and cloning it to a different region, so that you basically kind of mimic having two regions and having a kind of business continuity solution. Ours is a little bit more automated than that. Just define your key to be in a multi-region, and it just exists there. Now, we recently also announced support for a global regional support, which means that if you create a key within a global region, that key becomes available across around the globe. So a key that's created, for example, in the United States, may be also available in India, or also available across Europe, if you create it as a global key. And for anyone who's actually worked directly with HSMs, you know that that is a pretty special thing to be able to do, because creating clusters with HSMs is not that simple, especially when it spans massive geographies. And because of the architecture that we chose, that Otto will explain in a bit, you'll see why we can actually do things like this, which makes it truly like a cloud service. The second thing I want to cover is attestation statements. What an attestation statement is that it's a statement that's signed by the HSM using a certificate by the HSM vendor that attests to the key and the properties around the keys being inside the HSM. So if you create a key with using our APIs, then you can download the attestation statement, verify the signature, and know that that key is definitively inside or created by one of our HSMs. And when you perform a crypto operation, it will happen within the HSM itself. Now, the other things you can do with that attestation statement is that you can look at the various properties of the keys, including things like whether the key is extractable or not. So you can actually get verifiable proof that that key material cannot be taken out of the HSM in plain text, and that Google can't do this either. And so this is something that will probably make your auditors very happy. Other things that you can do are, look at the different properties. One of the more interesting ones is that if you actually are using a asymmetric key, you can actually download the SHA-256 hash of the public key itself. So when you download the public key from Cloud HSM, you can take the SHA-256 hash compared to the one that's in the attestation statement. If they match, then you know that you're talking to the right key, and that you have cryptographic proof that you're talking to a key within the HSM. The final thing I'll talk about is customer managed encryption keys supported services. So all the services that you see here are already integrated with our Cloud KMS. So there's 9 of them listed in the integrated services. And on the virtue of the fact that we've designed Cloud HSM to leverage the exact same API, it means that anywhere where Cloud KMS can be used, you can actually leverage Cloud HSM as well. The only difference is, again, is that when you create the key, there's a different flag that you set. And so it's probably one of the fastest experiences you'll ever have in creating a key in HSM. And then with that key, you can actually use it to protect your data in, for example, Cloud SQL or GCS or BigQuery or any of the services listed there. The CMEK compliant services are services that don't persist data in any significant length of time, which is why they're CMEK compliant. And if you look at the URL that I have at the bottom of the slide, this page will be constantly updated with new services that we add, because we're constantly trying to add more services to the supported list for Cloud KMS and Cloud HSM. And with that, I'm going to add 3 more things that I want to actually talk about. So first, customers pay for key operations, not capacity. So what we're saying here is that Cloud HSM is actually a consumption-based model. You don't have to basically purchase an entire partition or partitions or clusters of partitions. You basically pay for every crypto operation, every key that you create. So I believe right now it's 3 cents per 10,000 operations for most type of operations, and it's about $1 a month per key. So you can use as much as you want, you can use as little as you like. It's basically, there's no kind of upfront cost to this, and there's no commitment. There's no additional cost for multi-regional operations. So despite the fact that this key can span multiple or like a vast geography, we don't charge any extra for that. It's basically the same cost that I just quoted above. And then finally, the high availability is inherent as a property of the service itself. So there's no requirement for you to actually take backups, store the backups, or do anything else like that. We have a very, very robust system that takes very, very frequent backups and actually takes the key material and actually backs them up into a disparate system as well, so that we're resilient against failures of any particular data store. So with that, now I'm going to turn over to Adit, who's going to talk a little bit more about the architectural overview.
Thanks, Ilsung. Like Ilsung said, I'll go into more details about how the architecture works, and I'll hopefully make it clear how all of the features that Ilsung talked about fall out of our design. I'll go more into detail about a lot of different aspects, but to start with, I want to talk about some of the design principles that we have behind our system. First, we want to reduce user API access. HSMs are inherently complex devices and are somewhat of black boxes. In order to try to prevent customers from launching attacks against the HSMs and the service, we want to restrict the types of operations they're allowed to do. Second, one of the major reasons to move to the cloud is to no longer need to manage your own devices. We want Cloud HSM to fit in that same customer experience. As Ilsung said, we want customers to pay for a consumption model, not for having to provision their resources beforehand. And third, a lot of customers have compliance requirements around where their keys are geographically located. We want strong cryptographic and administrative controls to make sure that we can maintain these requirements. The system that we've designed for these principles looks slightly different than a normal HSM in the cloud model. In the traditional model, you would have crypto op access, represented by the blue arrows, and admin access, represented by the red arrows, to your own partition on the HSM. The cloud provider would have admin access to the device as a whole, which they would use for operations like setting the HSM up initially for you. In contrast, in Cloud HSM, you only get crypto op access. That access is to shared partitions on the HSM, and it's mediated by the Cloud HSM service. Google retains admin access to both the partitions and the HSM device. The Cloud HSM service is responsible for load balancing and controlling access to the HSM. It can see plain texts, but can't see key material. Since these are FIPS devices, raw key material must remain on the HSM. Instead, the service can see wrapped key material, which it uses extensively in the system to make it scalable and highly available. Each region has a wrapping key that's replicated to a partition on all of the HSMs in the region. When you create a key, the service wraps your key with the region's wrapping key and collects the attestation. It puts the wrapped key in an external database. When you want to do a crypto operation, the service will retrieve the wrapped key from the database and send it to an HSM along with the inputs to the crypto operation. For example, with the plain text in an encryption. The HSM will unwrap the key and do the operation. This scheme has a few benefits. First, as soon as your key is created, any HSM in the region can use it immediately. There's no synchronization mechanism that needs to happen online. Second, the durability of your keys isn't tied to the HSMs. Your keys are all backed up in an external database. And third, regardless of the number of operations that you have or the number of keys that you have, all customers experience the availability of being backed by a full region's worth of HSMs. In order to scale up in this model, we'll install a new HSM in the data center for the region and clone the region's wrapping key to that new HSM. Additionally, if the region is supposed to support a multi-region, we'll clone the multi-region's wrapping key to a separate partition. For example, here we have 3 cloud regions, the first 2 of which also support the same multi-region. The HSMs in the first 2 cloud regions have a second partition that is cloned with the same multi-regional wrapping key. The HSMs in Cloud Region 3 don't have the second partition because the region doesn't support the multi-region. When you create a key in a multi-region, the process looks very similar to that as a region. The Cloud HSM service creates the key in the partition and wraps it. This means that as soon as you create a key in a multi-region, it can be used immediately anywhere in that multi-region. We bootstrap off the rest of Google's synchronized databases. Also, by using separate wrapping keys for different regions and different multi-regions, the service ensures that keys can't be used outside of their intended region. For example, a key wrapped with the Region 1 wrapping key can't be used in Cloud Region 2 because none of the HSMs in Region 2 can load that key. Likewise, a key wrapped with the multi-regional wrapping key can't be used in Cloud Region 3 for the same reason. This ensures that once we've set the system up, it automatically enforces regionalization constraints. Setting the system up, that is, cloning the wrapping keys across different HSMs, is an administrative operation, and we have a different set of controls to make sure that happens safely. First, only a small number of Googlers have permission to perform admin operations. The operations require M of N authorization on the HSMs. So the HSMs require multiple Googlers to authorize each operation, and Googlers need to provide 2-factor authentication in order to do so. All of the operations happen in a secure and highly restricted access facility. We have extensive audit logs, both for access to the facility and all of the operations that happen inside. Additionally, as Ilsung mentioned that these are FIPS devices, they don't allow specific operations regardless of who is doing them, even HSM administrator. For example, you can't export plain text key material of either customer keys or wrapping keys. And finally, many of our systems are built in such a way to not allow HSM administrators to perform crypto operations even with administrator credentials. We have all of these mechanisms in place to keep you safe from Googlers. Other customers, on the other hand, only have crypto operation access. So to keep you safe from them, we have a different set of mechanisms. First, when a customer does an operation, we check whether they have permission to do the operation in Cloud IAM. By using Cloud IAM, you can use the same set of permissions and policies that you use to manage the rest of your cloud resources to also manage your HSM keys. Second, we check that the customer has sufficient quota to do the operation. In order to make sure that we have enough resources to serve requests for your workloads when you need them, we need to make sure that other customers aren't unexpectedly overloading the service. And third, we have basic request validation before the request reaches the HSM. For example, we check that different arguments are within their expected range in size and also that the key types are correct. This, coupled with the fact that there is no customer admin access, significantly reduces the attack surface available, creating a safer product. In summary, we've covered quite a few details about how the Cloud HSM service works. We've seen how we use key wrapping and partitions to make a highly available and scalable service that takes away the need for you to manage your own HSM devices. We've seen how this system keeps you safe from both Googlers and from other customers through our administrative controls and tenant isolation. We've seen how you can easily create keys in regions and multi-regions. And the consequence of all of these design decisions is that it is as easy to protect your data both in Google services and directly as it is with a software key. We'll have all of these details and more in an upcoming Cloud HSM white paper, so please keep your eye out for that. Thank you.